Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 6.6, solving absolute value inequalities. All right, so no warm up today. We're starting right into notes. So find solutions to absolute value inequality with a less than symbol. Okay, so guess and check all solutions of x that make the absolute value of x less than 2, and then graph the number below. So we're trying to think of what numbers could I plug in for x and get true statement. Okay, so for instance, I could probably plug in 0. The absolute value of 0 is less than 2. That works. So 0 would work. 1 would also work because absolute value of 1 is 1. That's less than 2. All the stuff between 0 and 1 works. And it doesn't stop working until I get to 2. So I put an open circle on 2 because the absolute value of 2 is equal to 2. So that doesn't work. It's not less than, but the absolute value of 1.99999, or as close as I want, could get really close to 2 and still be true there. So 1.999 is less than 2. All right, so now let's try going backwards. So how far backwards can we go? Well, the absolute value of -1 is 1. 1's less than 2, so I can shade all the way down to there. The absolute value of -2 is 2, and 2 is not less than 2, so I'm going to have to stop again when I get to 2. So what ends up with is this graph where I have empty circles on -2 and 2, what would normally be the solutions to this one, and then I fill in between, okay? And the in between are the things that are going to be smaller than the solutions on either side once I do their absolute value. So now this graph should look familiar to you. Well, what kind of compound inequality graph is this? Well, this is really, if I split this, now rewrite it as a compound inequality, this is really x falls between -2 and 2. So this is really an and graph. So an absolute value equation with less than turns into an and compound inequality. Okay? All right, let's take a look at what happens when we have the absolute value is greater than. Okay, so find the absolute value inequality with a greater than symbol. So once again, we're going to guess and check solutions to this one now. The absolute value of x is greater than or equal to 2. So let's try 0 first. The absolute value of 0 is 0. 0 is not bigger than 2, so that's not going to be a solution. So we might try 1. 1's not bigger than 2, so that's not a solution. The first place it's going to work is at 2. The absolute value of 2 is equal to 2. So I have a filled in circle on here, and anything bigger than that is going to work. So 3 is greater than or equal to 2, so is 4 and 5 and 6 and all the decimals in between those. Okay. If we work back the other way, it doesn't start working again until we get to -2. Okay, so the absolute value of -1 is 1. 1's not greater than 2, but the absolute value of -2 is exactly 2. Okay, so 2 is equal to 2. And then if we did the absolute value of -3, we get +3, and 3 is greater than 2. So the absolute value of -3 and -4 and -5 all work along with the decimals in between them. Okay, so now rewrite the absolute value of x greater than or equal to as a compound inequality. Well, let's take a look at our graph. This graph looks familiar. Graphs that usually point outwards with nothing in between are almost always OR graphs. So it's going to be an OR. So this turns into x is greater than or equal to 2. That's this half of the graph. Or x is less than or equal to -2. That's this half of the graph. So we could take a greater than and turn it into a compound inequality also. Just uses OR. So less than turned into an and greater than turned into an OR. And notice in both cases, we just use the number 2 and its opposite -2 to sandwich it. So here we use 2 and -2 again. All right, so let's take a look at some problems like this. If you look in the book, you're going to see this definition. The absolute value of ax plus b less than c can be rewritten as a compound inequality where you take the inside of the bars and you sandwich it between +c and -c. Okay, and if it's a greater than, we take what's inside the bars and we set it less than -c, less than the negative, or greater than the positive of c. Okay, so less than turns into and, greater turns into or. So this one's a less than. So it says solve inequality and then graph your solution. So let's see. We solved this one easily. We just translated directly. So right to an and statement. It's going to be less than 3.5 and greater than negative 3.5. So this is a nice easy graph. Here's 0. Here's 3.5. Here's negative 3.5. And we are between these two. These are all of the answers, okay, whose absolute value is less than 3.5. All right, number 2 is a greater than, so we're going to use the or one and translate it. So this says, okay, I'm going to start with x plus 2, and we're going to change it to less than negative 1, or x plus 2 greater than positive 1. And it had an equal to bar, so we put the equal to bar there also. Okay, so x plus 2 less than negative 1, okay, or greater than positive 1. This one's a little harder to remember how to translate. So then we subtract 2 from both sides to get negative 3, or we subtract 2 from both sides here to get negative 1. So there's 0, 1, 2, 3, 4, negative 5. And we have 2 sides to this. We have x is greater than or equal to negative 1, so that's a filled in circle on negative 1, shade it to the right. That's this answer. Or x is less than or equal to negative 3, so that's a filled in circle on negative 3, shade it to the left. Okay, so we get our or statement from this. What I usually do is I start with the positive one though. So if you just drop the bars, you get this one. And then I go, okay, then I just flip the greater to less and the 1 to negative 1. And that's how I remember which one gets the 1 and which one gets the negative 1. So when it's a greater than, drop the bars, there's one of your statement, and then flip the greater to less and change the 1 or whatever number is on the right side to negative 1. Okay. All right, number 3. The problem with number 3 here is the absolute value part is not isolated. So in order for us to use our formula to split this into a compound inequality, we have to get the absolute value of our part by itself. So we'll add 4 to both sides to make 9. And then we can split this. This is going to be less than, so it'll split to an and. So you drop the bars away, and then you go in the back and put greater than the negative of that 9. Okay. All right, now we still have to solve this compound inequality. So we got a little more work to do. Subtract 3 from all 3 parts, and then divide by 2. So negative 6 is less than or equal to x is less than or equal to 3. Right, now if I graph this, here's 0, 1, 2, 3, 1, 2, 3, 4, 5, negative 6. And we have a filled in circle on negative 6, a filled in circle on 3, and our solutions is everything in between. All right, number 4. Same kind of thing here. We have to first isolate the absolute value part. So think of this thing right here as just x, and then this as 3x minus 8 is greater than 13. So we should add 8 and then divide by 3. Okay, so we'll do that. So let's add 8. This will become 21. And then divide by 3. And this will become 7. And now we have a greater than, so a greater than is an or. So like I said, you can just drop the bars and you get half of your or. And then change it from greater to less, and then make the 7 become its opposite, and you get the other half of your or. Now you solve these, so we're going to add 6 to both sides. So give me 13. And then we'll divide by 5, and 13 divided by 5 is 2.6, I think. Or let's check it just to be sure. 2.6. Or on the other side, we're going to get 5m, and then we'll add that on. It'll give us negative 1. And then divide by 5, and we'll get negative 0.2. So we're between negative 0.2 and 2.6 as our two solution numbers. So here is 0. I'm going to put negative 0.2 right here. And then that's 0.2, 0.4, 0.6, 0.8. Oh, that's not going to work. Try that again here. So we're going to do this way then. Here's 0. Here's negative 1. 1, 2. There's 3. And then I'll plot it this way. I'll say, okay, first one greater than 2.6. 2.6 is a little more than halfway. So we'll write 2.6 above my dot, and this is all the stuff greater than it. And then we have less than negative 0.2. So I'll put my circle at negative 0.2. And then less than is down this way. Okay. So I just estimated where 2.6 and negative 0.2 were when I do it by whole numbers on my number grid. Okay. We have 2 problems left here, so let's try these guys. Absolute value of 8 minus 3x is greater than or equal to 7. So the absolute value bars are already isolated. So what we need to do is just split this into either an and or an or statement. And greater than turns into or. So this is going to be 8 minus 3x is greater than or equal to 7. Or 8 minus 3x is less than or equal to negative 7. Okay. All right, let's see. So subtract 8 from both sides. So give me negative 3x is greater than or equal to negative 1. Divide by negative 3, we'll get positive 1/3. But notice this switched here. So this has changed from greater to less than. Okay. Same thing over here. Subtract 8 from both sides will give us negative 15. And then divide by negative 3 is going to switch this to greater than 5. So here is the answer to ours. And we want to graph it also. So there's 0, 1, 2, 3, 4, 5. So our first one says greater than or equal to 5. And the other one's got 1/3, so 1/3's about right here. So we'll write 1/3 above it, and we'll shade the less than or equal to part. Okay. Notice they're filled in because we have the equal to bars. So 1/2 goes to the left and 1/2 goes to the right, which is what usually happens on an or statement. Okay, so our last problem here, number 6. We got negative 2, absolute value of 1/2 x minus 4 is greater than negative 40. And you might look at this and say, oh, absolute value greater than negative 40 is not going to work for me. But remember, we have to isolate the absolute value bars first. So I'll divide both sides by negative 2. And that's going to flip my inequality sign to less than. And now we have a positive number on the side, 20 now. So it changes from greater than negative 40 to less than positive 20. All right, so remember less than is an and. So first you just copy it without the bars. And then you go in back and you make it bigger than negative 20. Okay, so 20 changes to negative 20. And bigger, even though the inequality sign doesn't flip, it's still eating the x part instead of not eating the x part like it did when it said less than 20. Okay. All right, so we're going to add 4 to both sides to get negative 16 is less than 1/2 x, and then add it to the right side also, and this will give me 24. And then we'll times by 2 to all the parts. We'll get negative 32 is less than x, which is less than 48. And now we're ready to graph because this is our solution. So remember, less than turned into an and inequality. All right, so if we go by 16s, this actually works out pretty good. 16, 32, 48, negative 16, negative 32. And we have an open circle on negative 32, an open circle on 48, and we shade everything in between. All right, this concludes page 2. We have one word problem on the back. You are planning a committee for a school dance. Ticket sales for the last 10 dances are 133, 178, all the way up to 198. So there are 10 dances. Find the mean number of tickets sold. So remember, mean is the average. So we're going to add them all up. So 133 plus all the way to 198. and then divide by how many they are. When I add them up, I get 1820. And if I divide that by 10, I get 182. So the average number of tickets sold was 182. Okay, on part B, the dance committee estimates they will sell the mean number of tickets with an absolute deviation of at most 40. How many of these ticket sales to the previous 10 dances were within this range? All right, so here's our thing, our given number minus, so x minus our given number, which was 182 for the mean. We want an absolute deviation of at most 40, so at most, remember, is less than or equal to 40. Okay, so the absolute deviation 40 is at most, then the given number minus 182, our target number. Okay, so if I solve this, this is an and statement, so drop the bars, go in the back and change it to negative 40, and then add 182 to both sides. So this will be 142 less than or equal to x less than or equal to 222. So how many of these these previous ticket sales fell within this range? So this, if you think about it, is the absolute deviation of 40 away from 182. So 40 bigger than 182 is 222, and 40 smaller than 182 is 142. And we want our ticket range to fall within this. So at most 40 away. All right, so we go back and count now. How many of them are between that? Well, 133, no. 178, yes. 205, yes. 220, yes. 186, yes. 142, yes, because it's equal to. 138, no. 204, yes. 216, yes. And 198, yes. So we had two ticket sales that didn't reach. So how many did? So 8 of the dances fell within the range of 142 to 222. Okay. All right, this concludes the notes for the day. There is an extra credit opportunity here. So your follow-up for 5 extra credit points, you can complete the Khan Academy recommendation absolute value equations. These absolute value equations are a little harder than what's required in Algebra 1. It's more of an Algebra 2 task, but you could still do them. I have an example down here which I'll go through really fast, which will help you. The only difference between what we did and what they have is they have the absolute value bars on both sides here. So it's a really quick fix. Think of this member as just an x here. So this really says 2x plus 10 equals 4x plus 6. And our first step might have been to do minus 2x to both sides. Okay, that's what they did here. They did minus 2 times the absolute value of x plus 1 to both sides. And that left us with only 2 times the absolute value of x plus 1 on the right side and nothing left on the left side. And then from there, it's just like problems we've done already. They subtracted 6 to both sides, divided by 2 to both sides, and then they isolated the absolute value bars. And then they split it into 2 problems and solved the problem separately. Okay, so those kind of problems are going to show up in the Khan Academy if you choose to give it a try. It is worth 5 points of extra credit. I will see you next time in class.